All right, so today we are looking at chapter 4, and we'll look at 4.1 today. So chapter 4 is reactions and the environment, and 4.1 we're looking at today is fossil fuel combustion. So just a little bit of background here. So chemistry has allowed us to harness the energy stored in oil, natural gas, and other fossil fuels to power our vehicles and industries, our homes, and so on. And in some parts of Canada, pollution from combustion reactions has created acid deposition. So this picture on the right is showing a forest that has been damaged by acid deposition, and we'll talk about acid rain, acid deposition a little bit more as we go through the slides. And lastly, combustion reactions lead to global climate change and acid deposition, and we'll talk about that a little bit more as well. So firstly, this is just another example of combustion reactions and the damage and the harm they can create. So for example here, the Halifax explosion in 1917, December 6th, 1917. It was one of the largest, most violent human-made energy-releasing chemical reactions in history, which killed about 2,000 people and injured about 9,000 others. All right, and here fossil fuel combustion is what we're going to talk about. So fossil fuels like coal and oil, natural gas, they provide the energy to power our cars, our vehicles. They also provide heat to appliances. For example, this gas stove burner. They're also used to heat up our homes, for example, in the furnaces and so on. So here we're just looking at other examples of using combustion, and we call combustion is the burning of fossil fuels. So turning on a light bulb, using an electric hair dryer, driving a car, getting a ride on a bus, heating your home with a natural gas furnace, using natural gas for the water heater in your homes, so you can have a warm shower or bath. That's all using combustion of fossil fuels. So what are fossil fuels? These are the energy resources from the decayed remains of ancient plants and animals. In most cases, the energy stored in fossil fuels must be transformed into other forms of energy before it can be used. So combustion, which is also burning, it's the most common way to transform this stored energy. So basically what's happening is during a combustion reaction, we know that we need oxygen gas. So the fossil fuel reacts rapidly with oxygen gas, and it produces carbon dioxide gas and water vapor, as well as giving off energy. All right, it's an exothermic reaction. So in the process, you take that fossil fuel, it's reacting with oxygen, and it's producing carbon dioxide gas, water vapor, as well as giving off lots of energy. So here, for example, we are using octane. Octane is found in gasoline. It's reacting with oxygen, and it's producing carbon dioxide, water vapor, and energy. All right, so this is the word equation. Its chemical equation is when we use the chemical formulas. So we have 2C8H18, which is the octane. It's a liquid, plus 25O2, oxygen. O represents oxygen, and it's a gas. There's 16 carbon dioxides. It's also a gas, and 18 atoms of water, vapor. It's a gas. Plus energy is being released. So some of this chemical energy is transformed into kinetic energy. Kinetic energy is just the energy of movement. So basically it turns the wheels of the car so that the car can move. But also a lot of the energy is given off as heat, and you can feel that when you touch the hood of a car. All right, we'll pause it here, watch a couple of these videos. All right, so there's two types of combustion that can happen. There's an incomplete combustion, and this is when fossil fuels do not burn completely. They undergo this type of chemical reaction, which is called an incomplete combustion. Basically, it occurs when there's not enough oxygen available. So, for example, it can occur in a blocked chimney, an inefficient furnace, or a car engine running in a closed garage. And that will produce 5 products. So we're looking at incomplete combustion. So carbon monoxide, carbon, carbon dioxide, water vapor, and energy. So those are 5 products that are produced in an incomplete combustion reaction. During a complete combustion reaction, there's only 3 products. It's carbon dioxide, water vapor, and energy. All right, so there's 2 extra products being produced in an incomplete combustion. It's carbon monoxide and carbon. And you may have heard of carbon monoxide. It's an odorless, colorless gas, and it's extremely poisonous. Basically, it combines with blood in our bloodstream, and it starves the body of oxygen, which will eventually cause death. And this carbon, the carbon that's produced, so that's the second product here, produced in an incomplete combustion reaction that causes black coating or soot like you would see in fireplaces. All right, so again, carbon monoxide poisoning. Here it's just showing excessive exposure to carbon monoxide can build up in the bloodstream. Symptoms include nausea, chest pain, irregular heartbeat, unconsciousness, and then death. And it commonly can be treated with pressurized oxygen to clear the blood. And it's most easily prevented with a carbon monoxide alarm. So you can get one of these alarms similar to like a fire alarm in your houses or in the garage to prevent carbon monoxide poisoning. All right, so next we're going to talk about greenhouse gases. So if we look at the diagram here, this is a greenhouse. And usually a greenhouse is used to grow vegetables and fruits all year long. And it basically prevents heat from escaping into the atmosphere. So a greenhouse, how it works is it traps heat and it prevents that heat from escaping out of the greenhouse. And the greenhouse gases, they work the same way to trap heat in the Earth's atmosphere. So for example, using fossil fuels to heat homes, provide energy for industries, generating electric energy, also cars and trucks. They also burn millions of liters of gasoline daily. So all of these combustion reactions are releasing millions of tons of carbon dioxide into the atmosphere. And what's that doing is that it's trapping the heat and leading to things like global warming. So natural greenhouse gases occur naturally, right? So for example, carbon dioxide, it's important to life on Earth. Plants need it for photosynthesis. All living creatures, including plants, they also produce it naturally as well. And all living things produce carbon dioxide, water vapor, and methane. And these are known as natural greenhouse gases. But the problem is the human activity, the burning of fossil fuels, which is increasing the greenhouse gases. Okay, so the natural greenhouse gases are very important because they do trap the heat in Earth's atmosphere and they prevent heat from escaping into space, and they help maintain our average global temperature of about 15 degrees Celsius. Without them, the average global temperature would be much, much colder, about negative or minus 18 degrees Celsius. So natural greenhouse gases are important. The problem with these greenhouse gases is the excessive amounts of burning fossil fuels, which is leading to global warming. And this is the long-term trend toward warmer temperatures accompanied by extreme climatic events and shifting of the climatic zones. It's also called global climate change. So we're seeing dramatic increase in extreme climatic events, glaciers are melting, sea levels are rising, and climate zones are shifting. And the real threat is actually the rate at which climate change is occurring. So climates are changing much faster than they did in Earth's past, and many species of organisms, they won't be able to adapt to this fast change in the climates. And eventually these organisms are going to become extinct because they can't adapt to it as fast as it's occurring. Some people, on the other hand, believe that climate change is a natural phenomenon. They say that Earth has gone through many ice ages with shorter periods of warming between the ice ages. And they think that the Earth and these species will be able to adjust. This is just an example of glaciers. Compared to 1978, look at this glacier in Peru, and look at the same glacier now in 2000, the year 2000. All right, so climate change, what is your position? So there's two positions. Climate change, so position one, there's a lot of evidence that the global climate has warmed significantly during the last century because of the increase of two greenhouse gases, carbon dioxide and methane. And it's because of the burning of fossil fuels, such as coal and gasoline, which is releasing tremendous amounts of carbon dioxide. Human activities like burning vegetation, landfilling garbage, growing rice in large paddies, keeping large amounts of cattle together in feedlots. These are all releasing large quantities of methane. And the level of these and other greenhouse gases released by human activities is what appears to be causing the current rapid global warming. The second position is Earth has experienced natural variations in climate throughout its history. In fact, the greenhouse effect maintains the temperature of the Earth at a level suitable for life to exist. Natural climate changes occur over a relatively long period of time. The change is gradual. Organisms will be able to adapt to the new temperature and precipitation patterns. So those are the two positions on global climate change. Today, many scientists are concerned about the rate of change. They think it's happening much faster than how it did in the past. So the question is, will species have enough time to adapt to the new climate? Some skeptics argue that there's nothing to worry about. Warmer temperatures will make Earth more hospitable for humans and other organisms. They also question the reliability of the climate models that scientists use to make predictions about climate change. All right, so we'll pause here and watch this short video on climate change. All right, so next we're going to talk about air pollution and acid deposition. So the carbon dioxide and many other chemicals in the air cause harm to living things or the environment, and therefore these chemicals are called pollutants. So air pollutants can cause many problems like asthma, headaches, irritation of the eyes, nose, and throat. It can also aggravate previous heart and lung conditions as well. And acid deposition, this is when the air pollutants, so those pollutants in the air, they combine with each other, or they combine with the water vapor in the air to produce acid precipitation or acid rain that has become more acidic. The more accurate term we use is acid deposition because dry matter as well as precipitation can cause these acids. All right, so here we're just looking at natural formation of acid deposition. All right, so here, first diagram here, we have a volcano. When volcanoes erupt, they release carbon dioxide and water vapor. They also release sulfur dioxide, which is SO2, and nitrous oxides as well, which is NO2. And these gases then mix with the water vapor in the clouds to form diluted sulfurous and nitric acids. So sulfurous acid and nitric acid as well. Another natural formation of acid deposition will be from forest fires. Forest fires release carbon dioxide and water vapor. The burning of wood releases nitrogen dioxide and sulfur dioxide into the atmosphere. And then both of these gases, they'll react with rainwater and they'll make acid precipitation or acid rain or acid deposition. So that's what's happening here. Now, human contribution to acid deposition is what we're looking at here. So air pollutants. So like air pollutants, acid deposition comes from both natural sources and human activities. So looking at these two diagrams, here we're looking at, for example, from vehicles, nitrogen oxides emitted from car exhaust react with rainwater to form nitric acid. And here, industrial smokestacks release sulfur dioxide and nitrogen oxides, which will again react with rainwater to make acid deposition. All right, so these human activities are contributing more towards acid deposition. All right, and then in turn, this acid deposition is going to harm ecosystems, they'll harm organisms, just like we saw that previous picture in the very beginning where we saw the damaged forest. All right, so we have one last video to watch, and then these are the questions from the textbook that you'll be working on. I'm just going to play this video.